Hello people of the world, Paul Whittakin back with the Universal Law of Numbers, and we're going to do things a little bit differently today, but I'm just going to start off once again just briefly showing us how we get the 285 code. I kind of started to do that, but there's a little bit more to it. But anyway, we'll go to the top left-hand corner and we'll look at 1, 4, and we'll just add two numbers together going down in sequence to the bottom. So we have 5, 9, 8, 6, 2, 3. Then we'll go to these two numbers in rows 4 and 5. And we get 5, 9, 8, 9, 2, 9. And then we'll look at rows 7 and 8. And we get 5, 9, 8, 3, 2, 6. Okay, so if we avoid the 3s and the 6s and the 9s, you can see that we get, the 582 code, which is also 285 or 852, because for all purposes here, it doesn't particularly matter in what order they are. They still perform the same function in the universal circle, the universal law of numbers. So another thing, I want to point out again, sort of the reason that this thing fascinated me so much in the first place was just that the way numbers have their, this property about them. So I've enclosed a number that, I wrote down, and it's got a decimal point, and it added up to 9. So that number is going to be a 9. So no matter what order that those numbers are in, whether or not they have a decimal point is not important. It will reduce to a 9. So if I throw any number on top of it, 6, 3 for instance, and add that to it, it will remain a 9, because anytime you add 9 to any number, it still remains that number. The 9 has a zeroing out effect. So it can be 6, 3 or 3 3s or 4 5 or 2 7. It doesn't make any difference. It won't change the number. It will still be a 9. And being a 9, it will obey the universal law of numbers, because 9, it squares, goes to the 3rd power, 4th power, 5th power, to infinity. It will always be a 9. Now let's say we threw a 3 on top of that. Well, 3s always square and go to any power to a 9 too. And if we threw a 6 on top of that, or anywhere inside of that number, it would become a 6, and it would square, go to the cube root, it would go to the 4th power, and on and on and on to infinity, and it would always be a 6. So, that's the commonality between the 3s, 6s, and 9s. So interpret that as you may, but there's a lot to be understood about that, and that's why this is a 369 code. So now we're going to throw a little bit of geometry into the picture today, and I started with that yesterday or last time, and what I want to bring to your attention is that the circle, well, it goes back a long way. It's not strictly an Earth thing even. Anywhere in the universe, look up from whatever planet you may be on, or it doesn't matter. You're still going to see a sun in the sky, and it's going to be a solar system, and it's going to be a circle, and you will recognize it as such. So what happens is the unit circle is basically understood either in radians, degrees, we can use pi, but if you look at it like this, you'll see that 3, 6, 9, the 0 plays absolutely no role in it per se. 3, 6, 9, 3, 6, 9, 3, 6, 9. So obviously there's nothing new about that. But why I'm pointing it out is because, it's just to reinforce the validity of the reduction of the numbers to single digits. Because it's not typically the conventional way of looking at things. But as far as the universe is concerned, it's not only showing that you can do it, it's somehow literally encouraging that it's done. Because, for instance, if we take this unit circle and write it this way, conventionally we go pi over 3, pi over 6, pi over 2, 2 pi over 3, 5 pi over 6, pi, 7 pi over 6, 4 pi over 3, 3 pi over 2, 5 pi over 3, 11 pi over 6, and 2 pi, which is exactly the same thing as doing it with the degrees. But, the reducing it works here as well, and that's what I'm trying to point out. So we have, we'll start with pi over 3. Now we're going to multiply. 3 times 1 pi, 3. 6 times 1 pi, 6. Well, pi over 2, you could say that's the same as 3 over 6 pi. That's fair. That's mathematically, allowable. And 6 times 3 is 18, and we get a 9. Now, it's pointing out something else too, because you can make it, 339, 666s, whatever it is, it's a 369 system. And you can make them into 3s, you can make them into 6s, you can make them into 9s, and, for whatever purpose you may have in mind. So we're just observing that particular property. So here we have 2 pi over 3, 3 times 2 is a 6. 5 pi over 6, 6 times 5 is 30 is a 3. Pi, which could be understood to be, a 1, but 1 pi, but it's also 9 over 9 pi, which is 9 times 9 is 81, and that brings it to a 9. Then underneath that we go to 7 pi over 6, 7 times 6 is 42, which is a 6. We come to 4 pi over 3, 3 times 4 is 12, which is a 3. 3 pi over 2 can also be understood as 9 pi over 6. 9 times 6 is 54 is a 9. We could change it into other things too that are mathematically allowed. And then we come to 5 pi over 3. 3 times 5 is 15, which is a 6. And then 11 pi over 6, that would be 66. 6 and 6 is 12, which is a 3. And we come to 2 pi, which can be understood also as 6 pi over 3. And 3 times 6 is a 9. So that's just another way of looking at it, following a 3, 6, 9 sequence. Okay, so I thought I just would like to point that out, because what we're doing is we are validating the fact that the universal law of numbers is valid mathematically. And once again, I'm not only talking to mathematicians or scientists, it's nothing to do with that. What I'm talking about is valid for school children, any person in the world, and it all applies to everyone, no matter what level of mathematical understanding a person has or doesn't have. This is all the beauty of this whole thing. So what I did was I drew some symbols on the circle which represent the codes, and the 369 code just comes out to be an equilateral triangle. There's nothing surprising about that, or new for sure. And, before you even do it for the first time, something like that is to be expected. And that's the beautiful thing about this. It's your intuition. Before you even do any of the simple calculations, your intuition tells you that something is going to come out of it. You're going to get the right answer. So here I just drew the lines together with the 528258 825 code, and we get a similar equilateral triangle. It's not only similar, it's identical. And if we draw the lines together, 174, 417, 714, it's also an identical equilateral triangle. Now, when I draw the 181 code, it's just a straight line. There's nothing else it could possibly be, because we're going from 1 to 8 to 1 to 8, from 1 to 8, and you know, that will never change. And then I'll show you what 248751 looks like. Okay, so there's a couple of triangles in that as well. They're just not connected at the top or the bottom. And it looks like we have those rectangular structures on both sides. And I think you could see a lot of different types of things if you really wanted to there. Now we will put them all together and we will come up with a structure that looks like that. Now, I'm in no way, shape, or form a person who has any artistic ability whatsoever, but I can admire that for its geometric symmetry, and I think an artist could have a field day with that, and you know, performing geometry upon that would keep you busy for a very long time. So then what I did was I just applied the universal law of numbers. And, you know, how did I do that? I just took the lines off of the code. For instance, I connected 1, 4, and 9, 1, 8, and 9, 1, 7, and 9, 1, 5, and 9. 1, 2, and 9, and all of the other ones. 7, 7, and 9, 1, and 8, and 9, 4, 1, and 9 is the same as 1, 4, and 9. And up comes this very interesting geometric form. And it's in ink. So I don't really know how well what you can make of that when you try and identify that. But I suggest, for your own purposes, you do one yourself, and for certain, you know, an artist could have a field day on that one, for sure. But what exactly is that structure? Now, I hypothesized, you know, that something was going to come out like the Great Pyramid. And in reality, if you peer into that thing, you'll see a multi-dimensional pyramid. It's like it's a pyramid in space with perfect symmetry. And whatever that thing represents, to me, what I've learned so far from this venture is that what this universal law of numbers is doing is it's trying to tell us things. And if we listen to it and we understand, I think it's trying to tell us, well, that's the shape of the universe, believe it or not. So that's my own interpretation of it. And if you have any artistic ability and are able to manipulate that so that the different shapes come out of it, you know, you will find that you have a multi-dimensional pyramid structure, and you know, literally infinite pyramids, if you will. So I think that's what the lesson is from that. Now I'm going to just quickly show you how to write your own universal law of numbers, and it's very easy. And that's another thing about it, and it follows the same principle as everything else about the universal law, which is basically, it kind of does the work for you. It's always telling you, you know, it will tell you how to do it. So anyway, we know that the nines are separated by 3, and they go on to infinity and they repeat themselves. So we just write 1, 2, 3, 4, 5, 6, 7, 8, 9 at the top. Underneath the ones, we write 3 ones, or 6 ones. Underneath the 3 6s and 9s, we write 9s. And that was easy. And then I'm just going to write the first line going across, because that's the way I came about to do it, which is easiest for me. So that's the first line. It's 149,779,419. And now we just apply the codes. Well, the easiest code is the one under 8. It's not hard at all to remember 181818. Right? Okay. So what about the sevens? Well, the sevens are 417, 4, 7, 1, 7, 1, 4, 7, 1, 4. Okay, so I wrote those out. So underneath the 4, it's 714, 714. Underneath the 7, it's 417, 471. No, it's not. Oh yeah, sure it is. I just don't have enough. 1, 2, 3. Let me see. Just going to fix that quickly. Okay, so we have 417, 417. Here we have 714, 714. And if you get mixed up there, one way that helps is it starts with a 1 and it ends with 789. So that makes that easy. And then all we have left is the code 248751. Okay, so I'll just write that on the first one. So underneath line 2, we had the 4. So start down here, 248751. Up here we have the 7. So we just do the 248751 on that one. And I've done that one, so we have 248751. A couple of helpful hints. We have the 729 and the 784. So that 784 and the 729, you can actually start writing the table based off of that, whichever way you do it. But I can assure you that it helps you. It's not even something so much that you memorize. It's something that sort of comes to you, because we know the 1s are underneath the 1s and the 9s are underneath the 3s, 6s, and 9s. And if you just remember a couple of the lines going across, let's say 189, that's easy to remember. The 119, that's easy to remember. And it gives you the cues, and you're off and running, and you have the code. And I hope you do have the code, and I hope very much that you use it. And I hope you have a very nice day. Peace and happiness to the world. Bye.